So this is a problem of hypothesis testing by using chi-square test. And the question is, in an experiment on 200 children with fever, half of them were given drug 1, chloroquine, and the remaining were given drug 2, calpol. The results are given in the following table. Test the hypothesis that drug 1 is no better than drug 2 for curing fever. Okay, so this is the table given in the question. Drug 1, drug 2, cure, not cure, no effect, and the total number. Okay, as a first step, we want to write the null and alternative hypothesis, that is H0 and H1. Here H0 is the attributes are independent, that is type of drug and effect of drug on fever are independent. Okay, type of drug and effect of drug on fever are independent. Okay, then next H1, alternative hypothesis. This is independent, so the alternative hypothesis is dependent. The attributes are dependent. That is type of drug and effect of drug on curing fever are dependent. On curing fever are dependent. Okay, so this is the null hypothesis and alternative hypothesis. Next, we want to find the test statistics chi-square. Chi-square is equal to sigma of OI minus EI whole square by EI. So first we want to make a table to find the OI minus EI whole square. So here the table we make is OI, first one, then EI, then OI minus EI whole square by EI. Okay. What are the values of OI? These are the values of OI: 63, 54, 24, 30, 13, 60. These 6 values are the values of OI. What is OI? OI is the observed value, observed frequency. Okay, so 63, 24, 30. 63, 24, 13, 54, 30, 60. Okay, these are the values of OI. Next, we want to find the EI values, that is the expected frequency values. EI values can be calculated by EI is equal to row total into column total by total. Okay, these are the expected frequency. Okay, that is in the first one, 63. Row total into column total. Here the row total is 100, column total is 117, and the total is 200. So here EI value is 100 into 117 by 200. Okay, and the value here is 58.5. Okay, in the next value 24. 54 into 100 by 200, and the value here is 27. Then in the next value 100 into 29 by 200, and the answer is 14.5. Here we can calculate the others. So the EI values are here 58.5, 27 and 14.5. Then in the next step, OI minus EI by whole square by EI can be calculated in the one stretch. OI minus EI, that is 63 minus 58.5 by whole square. We can calculate the square of that value and then divide by this value, 58.5. So this can be easily find out by calculating it in a calculator. So the value is 0.35. Like this, we can calculate the all other values, and the answers are 0.33, 0.18, 0.35, 0.33 and 0.16. So for finding chi-square, the test statistics chi-square, we want to find the sigma of this value. Sigma, that is the total of this value. So we want to find the total of these values, and the answer is 1.68. So this is the value of chi-square. Chi-square is equal to 1.68. Next, we want to find the degrees of freedom. DF, degrees of freedom. Degrees of freedom is R minus 1 into C minus 1. Here, R is 2. They have 2 rows. And C is 3. They have 3 columns. 2 rows and 3 columns. So, R minus 1 into C minus 1. That is 2 minus 1, 1. Into C minus 1. That is 3 minus 1, 2. Is equal to 2. So, degrees of freedom is 2. Here, we can take alpha is equal to 0.05. So, the chi-square alpha value can be taken from the statistical table. Degrees of freedom is 2 and alpha is 0.05. So, chi-square alpha value here is 5.991. 5.991. Okay. So, here the critical region is chi-square greater than chi-square alpha. Okay. So, here what is chi-square value? 1.68. 1.68 greater than 5.991, and this is a false statement. That is 1.68 is not greater than 5.991. So here we can accept H0. We accept H0. Okay. So here we can conclude that type of drug and effect of drug on fever are independent. So we can't say that drug 1 is no better than drug 2 for curing fever. Okay, thank you.